Hello and welcome to today's lesson on proving triangles are similar by AA. But first I have something for you to think about. I have a tree dying outside my house, 50 feet from my house as a matter of fact, and I want to cut it down. I assure my wife, no problems, I'll cut the tree down. Well, there is a problem. She doesn't always trust me. Well, as I'm thinking about how can I convince my wife that this is safe, I notice that as I'm standing next to the tree, my shadow is 70 inches and the tree's shadow is 48 feet. Will this information help me in my case for proving that I can cut down the tree? If so, is there actually enough information or do I need more information? So you might want to pause the video and think about that for a while. Alright, the section is 6.4. The title is Prove Triangles Similar by AA. Go ahead and write that down. So in the past we've talked about how to prove triangles are congruent. We had SSS, SAS, ASA, HL, and so on and so forth. But what we now want to do is how can we prove triangles are similar? And hopefully in class we were able to convince you of what it takes to prove triangles are similar. Now we'll go ahead and formally write that down. So we have the angle-angle similarity postulate. Notice it is a postulate. It's a postulate, not a theorem. So it's not a theorem. We're not going to prove it. It's a postulate. We are going to accept it without proof. And it goes like this. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So in this case down here, you see angle K and angle Y are congruent. Angle J and angle X are congruent. Therefore, we say triangle JKL is similar to triangle XYZ. Notice this symbol here. Similar. Not congruent, we use this symbol for similar. And we would say why? By a similarity. I apologize for my first grade handwriting. So let's look at an example. So we have two triangles, triangle XYZ and triangle BAC. Take a second, write these down. Alright. Well, at first glance, you probably notice that angle Y and angle B are both right angles. We know from before, all right angles are congruent, so boom, we have one set of congruent angles. But in order to prove that they're similar, we need two pairs of congruent angles. Well, right now you may look at it and say 53 is not congruent to 37, so we're stuck. Well, not exactly. Let's investigate a little further. This is 53, this is 90. The three interior angles of a triangle have to add up to 180. So, 180 minus 90 is 90. 90 minus 53 leaves us with 37 degrees. So, 37 degrees, 90, 90. Do we have two pairs of congruent angles? Yes, we do. So we go ahead and say triangle XYZ is similar to triangle. Now, if I started with X, then went to Y, then went to Z, I've got to go 53, 90, 37. I have to go A to B to C. So I'll say triangle XYZ is similar to triangle ABC. Alright, let's look at another example. So take a second, write these down. So, we want to prove that triangle ABE and ACD are similar. Well, what we have is a little triangle on top, a big triangle on bottom. Right now you can clearly see angle ABE is 52 degrees, angle ACD is 52 degrees. So we have one pair of congruent angles. We need a third pair. Or sorry, a second pair. Well, notice they both share angle A. So I don't know what the measure of angle A is, but I know it's in common for both triangles, so they have a second pair of congruent angles. So we can go ahead and say triangle ABE is similar to triangle ACD by a similarity. So let's look at part B. We want to show that triangle SVR and triangle UVT are similar. Well, at first you may look at it and say, I don't know anything about any of the angles. Nothing's marked. Well, you're right. But these little arrows mean something. They mean that SR and TU are parallel. So we're going to use that. We know from first semester that if these are parallel, alternate interior angles are congruent. So SRV and VTU are alternate interior angles, therefore they're congruent. Similarly, over here, TUV and angle BSR are congruent because they're alternate interior angles. And we can even go one step further just for good measure here. Angle TVU and angle SVR, they're also congruent because they're vertical angles. So we can then go ahead and say triangle SVR, sorry, I was edited there for content. Triangle SVR is similar to triangle UVT by angle similarity. So, the flagpole. Very common example. I don't know why they're obsessed about the flagpole, but here it is. The flagpole casts a shadow that's 50 feet long. At the same time, a woman standing nearby who's 5 feet 4 inches tall casts a shadow that's 40 inches long. Should sound familiar. So, first thing I'm going to have you do, and you guessed it, let's draw a little diagram. So, let me change colors. We got the pretty sun up here shining down. Oh, why is my sun green? Because I've never seen a green sun. Alright. Sun is casting its rays down to earth. There we go. Here's the ground. Let's pretend it's flat. Here's my flagpole. And here's my woman. Keep in mind, we don't know the height of the flagpole. I'll just call it H. We know the entire length of the flagpole's shadow is 50 feet. We know the woman's shadow is 40 inches. And we know her height is 5 feet 4 inches. Well, notice, we're kind of making an assumption here. The flagpole is straight up and down. It's perpendicular to the ground. We're also assuming the woman isn't leaning over. She's perpendicular, standing perpendicular to the ground as well. So, we have right triangles. But are these triangles similar? Well, look at what we have here. The sun is casting its rays down, forming the hypotenuses of both triangles. They share this angle of elevation. So these two triangles, the one formed by the woman and the big one formed by the sun, are similar. So we can go ahead and write our proportion. We'll say the height of the flagpole is to the shadow of the flagpole as the height of the woman. Now, let's go ahead and convert. We don't want to be using feet and inches. So 5 feet is 60 inches. So 5 feet 4 inches is 64. I don't know why I wrote inches. I mean, we don't need that for the proportion here. So h is to 50 is 64 is to 40. So we just need to solve our proportion. Go ahead and cross multiply. 50 times 64 is 3,200 divided by 40. If my ciphering is correct here, I believe that is 80 feet. So the height of the flagpole is 80 feet. Does that seem reasonable? I hope so. Alright, another example, very similar to the last one, but just to get one more under our belt. We have a school building that casts a shadow 26 feet long. Same time, a student standing nearby. The student 71 inches tall casts a shadow that's 48 inches long. So let's draw a picture. So you've got the building, you've got the sun. Sun casting its rays down to the ground. You got the person here. You've got the building here. The person is 71. Their shadow is 48. The building, I don't know how tall it is. I didn't climb it. But I know its shadow the whole way across from here all the way to here is 26 feet. Well, once again, we're under the assumption that the building's perpendicular to the ground, the person's standing upright, they're perpendicular. They both share this angle. The little triangle, the little right triangle created by the person, and the big right triangle created by the building are now similar by AA. So set up your proportion. The height of the building is to the length of the shadow, as the height of the person is to the length of his shadow. So after cross multiplying, I can solve for h. I get h equals 26 times 71 is 1,846 divided by 48. I get 38.5 feet. Or another way to say that is roughly 38 feet 6 inches. So hopefully we now understand one way to prove two triangles are similar is by showing two pairs of congruent angles. In other words, we have the AA similarity postulate. So hopefully now you have the tools to answer the question, can Mr. James safely cut down that tree without hitting the house? We'll see you next time.